Welcome to Walkabout the Galaxy, the quadrilateral astronomy podcast where the science is universal, the opinions are personal, and the cosmos is our playground. We are Strange, Charm, Up and Top, the Astroquarks, also known as Josh Caldwell,
Addie Dove,
Hannah Sargent,
and Jim Cooney.
Coming to you from the virtual Walkabout studio networked by the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. Follow the Astroquarks on TikTok, where we promise not to overload your feed. We are updating walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. You can contact us anytime at wtg@ucf.edu. And do contact us that way if you order a shirt so we can get it to you as soon as possible. Our stumper today is Fermi Paradoxical. I just finished a book. As you know, I was on vacation recently.
Lucky.
And I
Rub it
finished
in.
a book by Richard Powers, who won the Pulitzer Prize for his previous novel, The Overstory, a few years ago. His latest novel that was published last year in 2021 is called Bewilderment. And it features a planetary scientist / astrobiologist as one of the main characters, and that character models exoplanet atmospheres. And I was really impressed with how correct all of the science was in it. Like all the planetary science is just really...
The author himself is not a scientist?
No, he's a novel. I mean, he's a award-winning novelist. I don't know if he's taken some stuff, I don't know if he's
did his homework.
Yeah, he definitely did his homework. It was just very, very well researched, but it's sort of incidental. I mean, I appreciated that. Most people reading it, aren't going to care that much about it. But it's also it's a very nice book. But since they're dealing with exoplanets and astrobiology, one of the things that comes up in the book is the Fermi paradox and the Great Filter. And I was reading that, I was like, we used to talk about that all the time on Walkabout the Galaxy. I haven't talked about it in a while, and certainly not since Hannah has been with us. So I thought I would bring up a Fermi paradoxical stumper. The Fermi paradox, as you know, is basically, I like to describe it as time is bigger than space, at least within our galaxy. So you can get across the galaxy in 100,000 light years at the speed of light, but the age of the galaxy is orders of magnitude longer than that. So if aliens were so inclined and existed, they could have populated every planet in the galaxy many times over in a relatively short fraction of the age of the galaxy. So Fermi famously has supposedly said, well, if there are all these aliens, where are they? And one explanation for it is this idea of the Great Filter, which sort of
terrifying.
Is it not? Yeah, it's terrifying, Jim. So why don't we start with you?
Is this a Snapchat thing or a TikTok thing? Where is this
filter
being applied?
I know. The Great Filter, you apply it to your species, and it shows you the species in its best possible, like if it were a perfect species.
Amazing.
If it were it's the amazing filter, right?
Yeah,
that's the Great Filter.
You can use that on the TikToks, Jim.
All right,
that's right. Yeah, the Great Filter makes you look great.
Need something.
Makes your species look great. Anyway, Jim, do you think the Great Filter is behind us or ahead of us? And what do you think it is and where?
Old Jim, or young Jim 10 years ago said, the Great Filter's behind us and good things are ahead for us. 46-year-old Jim says, the Great Filter is just ahead of us. And no species can survive the fact that we're all still fundamentally, tribal
predatory.
And hateful, and now we have the kind of technology that can destroy ourselves like that.
Bummer. Let's see if Up and Charm can liven our moods. What do you think, Hannah?
I kind of just wanted to check the Great Filter being, because I had to go and wiki this before, because I've heard of Fermi paradox, but I hadn't heard of the Great Filter. So assuming listeners also may not know what it is, what is it? Is it the thing that stops us from
colonizing the galaxy?
From colonizing the galaxy, right? Yeah,
so that could happen, as Jim has suggested, at the point where you develop the ability to destroy yourself.
Right. Or that could happen
destroy yourself
way earlier.
But it also could happen at the step between bacteria and multicellular organisms.
Mm-hmm. So it definitely feels like it's imminent for us. I've grown up. My generation is very much, well, the world's going to end in our lifetime. So that's kind of the baseline level that we're functioning at right now.
Oh, that's terrifying.
I don't like it is terrifying, but I've kind of come to accept it after 30 years. But I feel like I don't think this is inevitable for species. But I think it perhaps is for us.
You think that it's ahead of us, but it's a porous enough filter that some species can get through it.
Yes, I do.
Okay, that's marginally more hopeful than Jim's outlook, right? And so there's hope for us as well as for other species out there. We can do it.
We can do it.
We can do it. Go team. What do you think, Addie?
Yeah, I mean, like the big thing right now, right, that would be sort of our filter is like, can we accomplish all the things that get us to interstellar exploration before like climate change ruins the Earth and we don't have other places to live? I think that's like sort of the big, right, existential crisis these days. And
one of them.
Well, yeah, one of them. I mean, that's true. I am still hopeful that the filter is that like we still have a path forward.
Do you think that are you in Hannah's boat where it's in front of us and that has like taken out maybe X% of other aliens, but we're going to make it through? Or are you, it was probably when we went from being fish to mammals or something like that?
I think that this like next step of, I think that like there's a lot of like evolutionary, like biological stuff that happens in a lot of the first steps, right? And those are very different than the sort of the technological evolution that's required to do the sort of colonizing other or expand. We're not supposed to use the word colonizing. I don't like using it, but like expanding to other locations, right? So I think that that's a different filter. So I think that there's probably like some species maybe have done it. I think it's a big one for, and I think also probably like the way you see the filter designed, right, is like the first, I don't know, there's some steps, right? And most of them are these like biological steps that are sort of like steps you need to change what your biology is and what your culture is as a result of that. And like, that's very different than sort of this giant last step, which is like have technology and then explore and then make civilizations elsewhere, right? Like I think that there's probably other steps in there, but because we haven't done them yet, we don't know what they are. And so like it's a lie. Like the last step for the filter.
The last step is really 50 steps. Yeah.
Giant leap, one might say.
Yes. Your description makes me think of things that we have in our lab, which is these sieves in the shakers that we use to separate particles of different sizes from like samples of, simulants of things like
sand,
materials
rocks
from the surface of the moon. And my Mrs. Strange is making an appearance on Walkabout the Galaxy here for all our YouTube viewers.
Yay!
Mrs.
Strange.
She did make a strange decision.
It's Dr. Strange and Mrs. Normal. Yeah.
Yes.
But I think you're probably right. There are probably multiple filters, and we have probably gone through many, and we should pat ourselves on the back for that. And there are probably more than one in front of us, as you were saying, Addie.
Yeah.
There's don't blow yourself up, but then there's also like having that cultural mindset to say, let's do that, because while it's physically, technologically possible, it's not obvious that beings would want to do that when they get to that stage.
Or that they can, like, as a global civilization, get along well enough to move forward to do those kinds of things.
Yeah.
Because it's not going to be like, anyway.
Well, today we're going to talk about IWOWs.
Just do this the whole podcast.
Yeah, I know. I had to stop myself chiming in.
Do you know what an IWOW is?
No.
And it's an interior water ocean world.
Oh yeah, I saw that in one of the articles, and I was like, "That's the first time I've heard them called that."
First time.
I like that.
Somebody's trying to make fetch happen, and it's not.
Yeah. I'm on board.
Well, we'll talk about IWOWs and water everywhere, and yet another strange neutron star. But first, this episode of Walkabout the Galaxy is brought to you by Skewness. If you're feeling a little off balance, maybe not as well centered as you would like to be, you may be experiencing skewness. This completely natural and healthy condition doesn't require any treatment. It's perfectly normal for your skewness to increase or decrease as your mood changes, as long as we use a Poisson distribution of integers to represent your mood. So when you feel your mean and variance are on the rise, don't be alarmed if your skewness is on the decline, and embrace your higher order moments. Skewness. Travel freely.
Ooh, is it some airline?
Yeah, it sounds like an airline.
Well, I'll give you a hint that I was inspired to reach out to Skewness and ask them if they'd be willing to sponsor this episode because it's coming up a lot in my research doing analysis of data of Saturn's rings from Cassini. But also, as I mentioned, I just returned from a vacation where we were all at one point feeling a little askew when we were on a boat, if you know what I mean.
Oh.
I don't know what you mean.
I mean, we were puking.
Yeah, so one of those
feeling like it.
Drugs you take.
Actually,
to stop
only one of us.
Oh, is it
Dramamine? Puked. It is Dramamine.
Good job, Jim.
Wow.
Congratulations.
I was not going to get that.
Jim said, "Is it a drug?" And I said, "Oh yeah."
Yeah. Congratulations.
Good job, Jim. He gets credit for that one.
I couldn't remember.
On the nerd news front,
did you have a scope patch? I'm just kidding.
I wish I had. I wish I had. But
what were you on a boat for?
Seeing whales, which we saw.
Did you see any?
We saw many.
Awesome.
Yes, it was great. On nerd news front, and speaking of aliens, has any of you seen a show called Resident Alien on Sci-Fi? Just second season just started this week.
No.
It's pretty amusing. Jim, you may recognize the star, Alan Tudyk.
I love that guy.
Yeah. So he's the star. It's pretty humorous. It's a classic alien out of water story. And it's pretty amusing. So its second season just started on Sci-Fi.
Writing it down.
Space news. There have been a lot of launches this month. From here locally, there was one scheduled for last night. Did it go?
It didn't go last night.
It did not go last night. Okay. It's still cloudy tonight, so we won't be able to see it if it goes tonight. But what we can see is none other than Charm Quark herself on the front page of UCF, whatever that means.
Yeah, whatever that means. It's like Florida Legislative Space Day yesterday or something, and so they've been doing like space stuff all week on the UCF social media and the front page and stuff.
Yeah.
Space is sexy. Done. Everybody likes space.
It is.
Yeah.
Well, we make jokes a lot about water discoveries, and then we've got a whole bunch of water discoveries this time around. We'll start at the moon and sort of work our way out. The first
just
sort of
like
moon
NASA's going to do.
Yeah, kind of. Yeah, it makes sense. It is nearby. Hannah, last episode, what?
Jim just gave us a thumbs down.
No, this was harkening back to a discussion we had like a year ago where I said we should do Mars first, and then Addie got all up on me about how that was stupid, and so did John. But Hannah, you weren't around. It's not an anti-moon thing.
Jim's anti-moon.
I'm not anti-moon.
He probably writes moon with a lowercase when he spells it too.
I do.
Who are you, Musk? Ugh.
Do you write sun with a lowercase? The sun with a small s?
Yeah.
Okay. Well, that's
right.
That's
anyway,
cosmologist
I apologize.
for you.
Moon first. There's water on the moon? Again?
It's a bit of a tangent kind of linked to to moon water. So you may have heard, we've talked about in the past, the Alcross impactor that went to the moon. So it was a spent rocket stage, and they thought they could use it, send it to a polar crater, and then a shepherding spacecraft could detect what was released, which included water. So that was one of the first sort of direct observations of water on the moon, which is really exciting. And now there's another piece of spent rocket exhaust going into the moon, but this is completely unintentional. So this is Elon Musk's fault. This is a piece of rocket that was launched in 2015, and it's just kind of been left to fall into various different gravity fields, and it's so what have they said? They said it's going to end up on they think the far side of the moon around 4th of March is the current prediction. And there's kind of mixed reactions. You've got those who have seen this as we're about to blow up the moon by accident, how terrible, which is not going to happen. I'm going to clarify that. Actually, I feel
but there's a movie idea in there, I feel.
No. But it's weirdly calm within the planetary science community from what I can tell, because everyone's just like, I mean, yeah, it will leave the crater and we'll see if we can monitor it. So there'll be the LRO orbiter. I think they're going to try and take some images before and after on the sort of predicted crash site, and maybe there'll be some effects on the exosphere of the moon. So any interactions of like the dust or debris, they'll try and see if we can monitor that, learn from that. It's not ideal. It's not like we're not saying, yeah, let's do this. It's just, okay, we'll see if we can learn anything from it. But if we can avoid doing this, please, can we stop sending random stuff onto the moon?
Well, it's not, and like you said, it's not the first time we've done it, actually, like, and it's not a big concern right now. Like, it'll be interesting to look for the craters, but in the future, if there's like stuff on the moon, maybe we don't want to just let random stages crash into it. But the Apollo 13, 14, 15, 16, 17, I think most of those at least, their spent stages were intentionally crashed into the moon. And that's because they were going to just
the moon up with junk before we even lived there.
That's all right.
I mean, in fairness, we're crashing much more stuff on our dear home planet than we are crashing on the Earth. So,
and when they did it with the Apollo missions, it was cool because they still had the lunar seismometers that had been put down on the surface, and so they used that to try to like look for the signal when it crashed elsewhere on the surface.
Do we not have seismometers on the moon now?
I mean, no. I mean, we haven't put them down since Apollo, so like they stopped operating them many decades ago. But there are proposals to put new seismometers that are better, higher quality.
Oh, yes, I want to see that.
Well, when is that impact happening?
So they think around 4th of March is the expected date.
Okay. And what part of the moon is it hitting?
They say far side.
I haven't seen anything more detailed than that.
Did you note there that Hannah, the European, said 4th March instead of March 4th?
I did.
Mm-hmm. Oh no, did I?
Mm-hmm.
Actually,
that's okay.
European.
It's not okay.
Mm-hmm. It is okay.
Oh, it's okay. I just.
I think it's the 4th of March.
Yeah, we say that sometimes, but Europeans do it all backwards.
I keep trying to get it right.
Is that a tagline, Jim? Europeans do it all backwards.
Moving on. If we may, to Mars.
Probably should.
On our next watery stop, there's new research. One of the issues, we've joked a lot about, water's discovered on Mars over and over and over again. It's usually been various discoveries of like aqueously altered minerals. So minerals that had to form in the presence of liquid water, and we find that. We know that there's a bunch of frozen water ice on Mars that we've known for quite some time. But there's been various discoveries like, occasionally maybe a little sort of miniature melting event or something like that happens. And then, of course, there are all these old riverbeds and old lake beds that we're exploring with all these cool rovers and things like that. But one question has been sort of like, well, we know water flowed on Mars, but was it like in these sort of brief, intense bursts of warmth, like maybe sort of a wildly gyrating climate that went between sort of very cold and very warm conditions, and then be very warm for a little while, and you have all the water melting and flooding and everything, then freeze back up. So not really the greatest environment for life or a vacation. Or was it, more like the Earth, where you had liquid water around for a long time? So new research says more like the latter, perhaps.
Yeah, there's it's interesting. So there's a sort of a new study that's done with data we've had for a while, actually, from MRO, which is the sister of LRO. This one's on Mars, and they basically have looked at sort of the extent of salt deposits. So we can track with these images like where salts are, and then using crater counting and age dating, they sort of determined how old those surfaces were, and that there seemed to be water that was flowing for longer than we thought.
That's good, right?
And that's exciting, right? Yeah.
Yeah.
Because that means longer. If you have longer puddles of water, then that's more time for a little green mentor.
That's right.
Yeah. So it was, I think the timeline is like, we sort of typically say that most of the water evaporated around 3 billion years ago. But this sort of put it as recently as 2 to 2.5 billion. So an additional billion years.
That's a lot can happen.
It's a long time.
It turns out that is a long time.
So many steps in the filter can happen in that time.
That's right. That's right. You can get through a lot of filters in a billion years.
Yeah.
So that's interesting, and somewhat hopeful for maybe prospects that life existed on Mars. What are your thoughts on that, by the way, group? Are we going to find evidence for past life on Mars?
Absolutely.
I think so.
Really?
Simple, very simple.
Yeah.
Yeah. Nice little microbe.
No, sure, but
microbial, yeah.
Yeah.
I mean, like, there's enough stuff that's just in like comets that is like the building blocks, and then if you have sort of the right environments for long periods of time, I don't see why not.
Yeah, there's certainly this like intriguing, though not definite, bit of evidence. Like on Earth, almost as soon as the conditions got right, life arose. Right. I say almost as soon,
and like thrived
within a few 100 million years of like the environment is right, it happened. So that's only obviously one data point, but it's a data point that maybe suggests that life itself is easy. Maybe those other things are hard. Like I think that like eukaryote, prokaryote thing is like hard, and intelligence, of course, only arose very, very recently, but
not yet.
Maybe not.
Right.
Speak for yourself.
Debatable. Yes. Yes.
But anyway, life itself, it's there. Of course, finding evidence of very, very simple life, I guess, is not so easy because they don't leave nice, clean fossils or anything like that for you to find.
Right. Right. Yeah. The fossils of ancient microbial life on Earth look like rocks to the untrained eye.
Yeah.
Yeah.
But there's a funny, like, with the whole planetary protection thing, I probably should wrap my head around it because I'm supposed to be looking for water on Mars. But the planetary protection, where we haven't previously headed too far northward or wherever we think there might be significant ice, because we don't want to contaminate places that have life. So we want to discover it, but without getting too close to it.
That's going to be tough.
Very tough.
Yeah.
Yeah.
I tend to be more skeptical than the three of you on this front.
Ooh.
I'm not expecting to see it.
Why not?
Yeah. I'm also, I have to say, a skeptic about finding it at the other watery places that we're going to talk about today, which are the IWOWs.
IWOW.
The IWOWs. I'm just going to say that a lot. So the IWOWs, interior water ocean worlds, are now, I guess they decided that they needed an acronym since they have potentially discovered maybe the fourth one of these. So we have Europa, maybe even more than four. Europa for sure, orbiting Jupiter, has a water ice ocean pretty far down underneath a pretty thick ice shell. And Europa looks like it. It's got all sorts of quote unquote youthful geological features on the surface. Enceladus at Saturn has got these famous geysers of water vapor spewing out of the South Pole, and it has youthful geological features to go with that, and lots of modeling has shown that it's got a subsurface ocean world. And Titan, the largest moon of Saturn, also. There's in my talks, which I'm now going to have to update all
Oh
my
no.
public Cassini talks, I make a comparison between Enceladus and its next door neighbor, which is Jim
Mimas.
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 I know.
AKA the Death Star moon, which is a very, very heavily cratered moon. It's a classic battered, beaten sphere with a really singularly large crater that, if the impactor that had made that crater had been maybe 10 times as massive, it would have shattered that moon into a gajillion pieces. But it doesn't look anything like Enceladus. So we say, oh, this moon is geologically dead and inert. It's a solid chunk of ice, and that's what you'd expect for a tiny little moon. It's only a few hundred miles across. And its next door neighbor, Enceladus, has got all this exciting stuff going on with geysers coming out, and all these fissures, and a very young surface, and all of that. So it's an interesting puzzle. But a new paper suggests that the Death Star moon itself also is likely to have a full global subsurface water ocean. IWOW.
Wow.
That is wow. I had not heard that. That's very exciting. How do they?
Yeah.
How are they? How are they detecting that? Why? Just because of its spin or something?
It comes back to this issue of libration and tidal forcing. So they're basically looking at all the little itsy bitsy wobbles of this moon, and it is on a slightly eccentric orbit. And so it's just really impressive what you can do with tides. It's not, something that we think of as a hugely powerful force, but over a planetary scale, if you add it all up, it can provide a significant amount of energy. And so as this little moon on its very slightly egg-shaped orbit goes around Saturn, it's very close to Saturn where tides are strong. So it's much, much closer to Saturn, relatively speaking, and even absolutely speaking, than our moon is to the Earth. And so tidal force depends very, very strongly on distance. When things are close to each other, the tidal force is much, much stronger. You move it a little bit further away, it gets much, much weaker. So the Death Star moon, Mimas, is closer to Saturn than Enceladus. So that would, sort of suggest stronger tidal forcing. But then it depends. You have to be wiggling. If you're just on a perfectly circular orbit, you just sort of lock into place and nothing goes on. So it is on this eccentric orbit. And they see evidence for the libration or the wobble of the part that we can see with our cameras. Putting that all together with the tidal forcing and the orbit suggests that the interior has a liquid water layer. Not too far beneath the surface, 20 or 30 kilometers beneath the surface. As far as these things go, that's not too far beneath the surface. But it hasn't been detected the same way it has with Enceladus, where we've actually observed the water vapor coming out from the interior. So it's not as slam dunk a case, but pretty interesting.
My question would be, how would you ever know? Because they think it would be quite deep, as in it would be a very thick shell, icy shell. So how do you confirm?
Yeah, so the model predicts a certain heat flux out of the moon, but it's small. Okay. It's in the tens of milliwatts per square meter. So you could, in principle, detect it without, drilling a hole 20 miles deep, to get down to that ocean. You could, in principle, detect it with a sensitive enough radiometer measurements of the surface of the moon.
If you have better gravitational measurements, does that help with the model?
That might. So
because you get that decoupling that we see, and they would tell you about the Q factor and different things.
That might. So having better measurements. So yeah, if you put an orbiter around the moon, which that would be a challenging thing to do, but if you put an orbiter around the moon, then yeah, you would get a really good idea of what the density profile of the interior of the moon is. I don't know whether I don't know the sensitivity limits of like the radiometer that would be needed to detect the heat flux that's predicted to be coming out of this, but obviously Cassini had a radiometer and it did not detect it because this predicted flux is below its limit of sensitivity. So it may be a more plausible thing to imagine putting an orbiter around that moon, and that's, I'm sure, not on like the top 5 priority list for future NASA missions at the moment. So,
you need like a Saturn orbiter with a bunch of little like sort of CubeSat style or ESPA style spacecraft that go orbit all the little moons.
Yeah, that would be cool.
Totally doable.
Be super cool.
Yeah. But this is certainly very, I find that very, very exciting because like every time when I first learned that Europa had water, I was like, holy crap, that's awesome. That's like whole nother realm of things to look for life and things like that. And then when I learned that Enceladus and Titan and all like, this is just like a wealth of worlds with water. That's
right. I mean, for when I was a kid, like what's so special about the Earth is one of the things that's so special about the Earth is the only object that we know of with liquid water, and that's the magic ingredient for life. And now
a dime a dozen.
I remember growing up watching they at the IMAX they would have like short screenings of like what we think the outer planets are going to look like and whatever else, and they would hypothesize like underneath these icy moons there were these basically dinosaur ocean animals like swimming around and everything. It was because it was a really cool and exciting new idea. And now it would be cool. I think the idea of there being liquid water elsewhere in the solar system, I think is so cool. And the idea of being able to test for or search for life there would be amazing. Rather than ancient life.
If there's like still something ongoing, because a lot of that is like current ideas of Earth life development or hydrothermal systems where you have heat and icy or water energy rock interactions, and so those could be happening in these places. You mentioned Death Star, Josh, and it made me think of a tangent. Is anybody watching the Boba Fett show?
I am.
Okay, not yet.
Yes.
Okay.
That's another new nerd news update on Disney Plus. Boba Fett, the Book of Boba Fett. Well, that brings us to our trivia, which will segue us to our final science topic, because the trivia is about pulsars, which is our last science topic. So now shifting from planetary, so Jim is finally going to be interested in the show.
I genuinely am very interested in all those other things. Very cool.
So as you know, hundreds of billions of stars in the Milky Way, but when they die, they become exciting things. One of the exciting things they can become is a neutron star, and if the neutron star is magnetized and oriented the right way, it produces a periodic pulse of radio waves, and we call these pulsars. So, of course, as you may have guessed, this is a multi-part trivia. So just as a lead-in, we're going to do the first one right now. What year was the first pulsar discovered by Jocelyn Bell?
Jocelyn Bell Burnell.
61. No, 63.
I can see the picture of her as well.
So you're going to try to figure it out from her hairdo or her fashion at the time.
67. I'll guess close to Jim, but not the same.
55.
Addie has it on the number. 1967.
Thanks, Jim.
Well done.
When she said that,
Jim's giving me all the answers today.
Yeah.
The pulsars very precise periods, so many of them spin fairly rapidly, and they're such a metronomic precision of these pulses of radio beacon that when they were first discovered, people thought, this is extraterrestrials. Maybe we've seen signals from some alien civilization. And so that precise, the accuracy that we can, measure that periodicity was used famously on the Pioneer spacecraft and Voyager spacecraft gold plaques to identify the origin system for those spacecraft in case aliens someday ever encountered these things, said, who built this thing? It included a map that referenced our system relative to some number of pulsars that are indicated by binary symbols indicating the periods of those pulsars. The question, the second of your three-part question is, how many pulsars were used on that plaque to indicate our position? We'll come back to that at the end of the show. And then finally, a single radio observatory has discovered more than half of all the known pulsars. Which one? Was it the Arecibo Observatory in Puerto Rico? One or more of several individual 70-meter dishes at the Very Large Array in Goldstone, California? Was it the 100-meter Green Bank telescope in West Virginia? Was it the relatively new 500-meter FAST telescope in China, or the famous Parkes 64-meter telescope, famous from the movie The Dish, in New South Wales, Australia? So we'll come back to that after Jim tells us about the latest cool pulsar news.
This, like every major news source has had an article in the last few days about this new weird thing. And this is an example of kind of, I don't know, the authors of this paper having really good publicity people, because it's interesting, but not like radically more so than a lot of the other things that we've talked about. They get
that don't get any coverage in the media.
Any coverage, yeah. But anyway,
except here, obviously.
Well, we talk about them all, but yeah, not all of them. This was like, like front page of CNN kind of thing, like a little bit weird. But anyway, kind of a cool thing. It's just, so we were just talking about pulsars, neutron stars, and they typically spin very, very quickly, right? So they, the first one that Jocelyn Bell discovered, I think, had a periodicity of like 1.3 seconds. So it spun around every 1.3 seconds, and that's pretty typical. A second or two, or even a tenth or a hundredth of a second are typical periods for how fast these things spin around. But even though they're ridiculously regular, they aren't over very long periods of time. So like if you wait long enough, they'll slow down because they're losing energy, right? As they spew out all this energy, then they're going to slow down their rotation. They're going to lose rotational kinetic energy.
How long is long enough?
Like a long time, like on the order of hundreds of millions or billions of years, these things will slow down, right? Okay. And so you'd expect there to be out there. I mean, when they're first born, maybe they spin around 100 times a second. But if you waited, 10 billion years, you're going to have some that are spinning much more slowly. But they're spinning much more slowly. They also, they've kind of spit out most of the stuff they're going to spit out, and they're not losing energy very much anymore. So they're going to be much dimmer. They're cooling off, and they're not as energetic, and so we don't see those. Except I think we just did, right? I think that they just released a paper that said they found this object that repeated every 20 minutes, which is much longer period than your typical pulsar. It only repeated for like a couple of months, so it did that like every 20 minutes, on and off for a couple of months. And then went away, which is probably like there was some kind of a quake inside of the pulsar, which released a bunch of energy for a little while, and that shot out, and it turned that magnetic energy into radio light, and then we saw it blipping on and off for every 20 minutes for a while, and then that energy is dissipated and it's gone. So that's pretty cool. I mean, that's an object that we predicted might exist, but is really, really hard to see because they're just so dim. And we think we saw one. So that's pretty cool.
That sounds like front page news to me.
So, I think there's a couple of reasons why, at least from what I can tell, why it's made it onto the front page of so many. First of all, it's this whole, it's a detection of something, therefore aliens, and everyone just jumps on that train.
Sure.
And then earlier today, which really surprised me because it was on the news, on the TV, and there's this really nice graphic that's been produced to kind of highlight these magnetic fields and everything else. And then people were talking about it as if like this was a picture that was taken. Like, it's so beautiful.
Right.
That's not what it looks like, but okay. So I wonder if that whoever has like made some of these graphics has definitely like supported the dissemination of this story for sure.
Yeah. And I don't want to take anything away from this discovery or the folks who did this. I mean, it is a cool thing, and it did get, it got published in, if you do something really cool in astronomy or any of the sciences, the two biggest peer-reviewed journals are Science in the U.S. and Nature in kind of Europe or whatever. So this was published in Nature,
Europe or whatever,
some out there, the rest of the world.
I know my place.
But either one, Science and Nature, if you get it published in those things, are big deals. So this is a Nature paper. This is a big, a significant discovery. So I don't want to take away from how cool it was. It's just weird because we've talked about some of these. It's just another weird, different kind of class of thing that we hadn't seen before. So I guess in that sense, it's kind of a cool thing.
And there was like some mystery, like you said, to like, it wasn't exactly repeatable. It was a little bit different, but that's observing conditions. And like you said, if it's older and having some,
I mean, there's also all kinds of questions about this. I mean, we don't look for things like that because we know pulsars pulse every, really fast. So when you look for things, you look at them for a few minutes at this part of the sky, and then you move the telescope and look somewhere else. And so this wasn't, they didn't find this like specifically looking for it. They found it like in archival data from old stuff. And so it would be interesting to look back at this spot and stare at this spot for a nice long time now. It's not very far away. It's only like 4,000 light years away or something, this object. So galactically speaking, that's pretty darn...
it's in our neighborhood.
Pretty darn close. And it's probably pulsing regularly every 20 minutes, but most of the time its energy is much lower than our detection levels. But hey, pretty cool, I thought.
Yeah.
All right. Well, maybe that's something that if it's in the right part of the sky, that giant radio telescope in China can look at.
Is that a hint, Josh?
Maybe it is. Maybe it's a misdirection.
Oh.
Maybe that's
psychological games that Josh plays with these things.
Yes. So, which radio telescope has discovered more than half of all known pulsars?
Wait, are we answering out of order?
We are answering. We'll come back and do the Voyager Pioneer thing. Since Jim mentioned sensitivity of detection, it made me think about telescopes. So your choices are Arecibo, the Very Large Array, the 100-meter at Green Bank, the fast 500-meter in China, or the Park 64-meter in Australia. Which of those radio telescopes has discovered more than half of all known pulsars to date?
Very Large Array.
Hannah goes VLA.
I think it's fast. I feel like they had a big data dump where they found a bunch of stuff recently. I don't know.
Okay. Jim, what do you think?
I will go with Arecibo.
Once again, I have stumped all three of you.
What?
Yes, it is the Parkes Observatory in Australia.
Nice.
Yeah. You should have done that one, Hannah.
I know. My heart is with the Parkes telescope.
Yeah. FAST did take a big dump recently.
Oh my!
But they've got it.
We felt better afterwards.
Yeah. But it was so they're discovering pulsars, but they just haven't been online long enough, and that's not the only thing they're doing, and so forth.
There was something that came out after it had been turned on that it had discovered a huge number of something, but I don't remember what it was.
Yeah, the total number of pulsars, any guess? I don't have an exact count because I don't have the most up-to-date numbers, but any guesses on order of magnitude of how many pulsars we know of in the...
I've seen several pulsar talks over the last couple of years from our Arecibo colleagues, and I feel like I should know these answers, and I'm doing miserably.
I want to say it's order of magnitude 10 to the 3, like 1,000-ish.
That is correct. That is the correct order of magnitude.
Yeah.
So how many of those 10 to the 3 did we put on the Voyager Pioneer gold record to be the map to the home?
24.
I'm going 4.
Hannah says 4. Jim says 24. Addie, you have a chance to get this one right on the number.
Well, that means that we didn't get it right on the number, Hannah.
7?
Yeah. I retire.
7?
14. I was trying to give a little hint before 14, 24. Yeah.
Oh, 14. Yeah.
So, But if they wait too long to discover it, then the timing will be off, as Jim was describing, because those pulsars are gradually slowing down because of the stupid conservation of energy.
But I think if you interpret it correctly, I think it points to a singular place and time in the galaxy because they do slowly change. There's only one point in time and space in our galaxy where there would be that timing in those directions, and so
that's
right.
If they were bright enough,
everything
they could figure out everything.
Everything is moving, just as we were describing recently, with the sun currently passing through a little bubble, but it's not our bubble, our supernova bubble. Well, while it may have felt like waiting to discover extraterrestrial life, it was just another episode of Walkabout the Galaxy. Give us 5 stars, and we'll give you 500 billion. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our episodes, some of our bloopers, and soon, astronomically speaking, 2 music videos.
Oh.
Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG or ask us at WTG@UCF.edu. Our theme music was composed by Richard Jurusik. Thanks to our listeners in Bavaria and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
I'm Hannah Sargent.
And I'm Jim Cooney.
We're the AstroQuarks, signing off until the next episode of Walkabout the Galaxy.
I don't have anything.
IWOW.
IWOW.